Example number 4, what we're going to do is decay. So now radioactive decay, we measure things in half-life. So let's define what half-life is. Half-life, it is the amount of time for, and I'm going to get real informal, for half the stuff to decay. Now that means go away. So what happens is that some radioactive materials, they just kick out part of their matter, and the half-life is how long will it take for there to be one half of the matter left over time. And so the half-life of a certain radioactive substance is 20 days. So for our example, it says that our half-life of a particular radioactive substance is 20 days. So that means if I started with 1 kilogram and came back 20 days later, there'd be a half a kilogram. Does that make sense? And if I came back 20 days later, how much would be left? 1/4. So we have that ratio of multiplying by 1/2, multiplying by 1/2, and that's why it's exponential decay. So we're going to start off initially, our initial amount, I think I initial, did I spell that right?
Yes.
Is 5 grams of this substance, okay? So we're going to start off with 5 grams, and then we want to figure out how long will it be till we only have 1 gram left. So half of 5 is 2.5, that's 20 days. Half of 2.5 is another 20 days. So 40 days in, we're at 1.25 grams. So it's probably going to be about 50 days. So how can we figure this out? How can we figure this out? Well, we need to write a model. So what is our initial condition? So I'm going to write this out. Your textbook doesn't really write it out, but really there's lots of ways to do it, but it's going to be the initial condition, and so we'll call this the amount A sub 0 or A naught times the ratio R raised to the time over the half-life. And this is very informal, and then you set it equal to what you want, okay? Now what are we looking for? We're actually looking for 1, okay? So now let's fill in the blank. What is the initial amount that we're starting with? 5. What is our ratio?
Oh,
1/2, right? Because we're given in terms of 1/2. So every 20 days, we're going to have 1/2. And then the t divided by 20 is the amount of time in days, right? All right. And then we got to set that equal to 1. Now, what's the best way to solve this? Now, I taught you guys last year that we could go in and take the natural log and do all that fancy stuff. But for today, let's figure out the quick and easy way. Does anybody know how to do this the quick and easy way? I do. So what I'm going to do is let's just graph the function and then see when it equals 1. So one way to do this is if I come in here and I just graph the function. Now the function is actually 5 times, in parentheses, 1 divided by 2 raised to the, and I'm going to use x instead of t, divided by 20. That's my function, right? Now do you guys remember this trick? Y equals 1. Do you guys know why I did that? Because now if I hit graph, I'm going to have 2 functions. The first one represents the radioactive decay, and I'll zoom in on that in a second. And the other one represents the number 1. And so if we zoom out I'm going to zoom out quite a bit. Actually, I'm just going to set the window. We, at the beginning, guessed that it would probably be how many days? 50, 60 days? And that should be enough. And we're starting with a very small number, so my y value could be 0 to 6, right? Because we're starting with 5 grams. So now let's graph that. So this line here represents the exponential decay. And then the red line represents 1. So in other words, where these two cross, the intersection of those two lines is when my function 5 times 1/2 raised to the t over 20 is equal to 1. Now can I on my calculator find that intersection? Yeah. So if I hit second calc and I want to find the intersection, I just come down here to intersect. And then it says first curve. So what I'm going to do is I'm going to try and get as close as I can on the first curve to the intersection. So I'm just going to slide in there as close as I can and then hit enter. And then it'll say second curve, and I want to make sure that I'm as close as I can be on the second curve. Hit enter. Then it says guess, and I think it's somewhere in there. I don't know. I can't see. Alright, so I'm going to hit enter. And it says that the intersection appears to occur at 46.43. So in other words, what they're saying is that when t is approximately 46, what is that? 46.44. This function should equal. So what does that mean? The answer is t equals 46.44, but what does that mean? What does that number represent?
How many days it takes?
Yeah, so I've got a radioactive substance. It starts off as 5 grams. It'll take me 46.44 days for it to become 1 gram. Now let's double check in the book and make sure that's the right answer. Yep, that's what the book says. Any questions? Cool.